Okay, so let's move into the worksheet number 4 from the lecture number 4. So lecture number 4, we mainly discuss about the Newton's 3 laws and how we're going to apply these 3 Newton's laws towards the problem solving, right? So now you have knowledge what is the Newton 3 laws are, but important thing is these 3 laws we are always keep applying for the motion of the object. Especially Newton's second law is most useful when you solve the problems in this course, in this whole semester, right? So everybody know that what is the Newton's second law is. Newton's second law is saying that net force, this is a summation sign, net force equal mass time acceleration. It is very important that this equation should be used with the directional information. That means you cannot just say force equal mass time acceleration without saying the direction. That means this formula should have a direction, whichever direction that you are using, you need to say it to the x direction or y direction, then solve the problem by using those linear equations, right? So it is with the direction. So now after we talk about the Newton's second law, we basically define what is the mass, what is the weight is, right? So mass and weights are two different physical quantities. Mass is independent of the value g, but the weight is depend on the g value, because you know that first force that we discuss is force of gravity, right? Force of gravity will be mass times g value. That means force of gravity always has the formula that you will be able to use. And also, yeah, there is a direction. This is always in negative y direction. That's the important information. And then we discuss about the normal force. So normal force, there is no formula that you can use for the normal force, because normal force is a elastic force that is depend on all the other forces acting on that object. That means you need to use the Newton's second law to find the normal force in that particular case, right? So, but normal force also has the direction that will be always perpendicular direction to the surface. Normal force is always perpendicular to the surface that contact between two objects. And then we talk about the tension force, right? So tension force and spring force, right? Those are working when we have a cord, we use it as a tension force. When you have a spring, we use it as the spring force, right? And tension force always we label it as a tension to the cord, force of tension, right? So next one, forces and also applied force can be any push or pull in any direction that you're going to apply, right? So those are the forces that we discuss, and according to the application, we need to figure out all the forces, what force will act, what direction it will work, and then you combine that into the Newton's second law and solve the linear equation to what the question is asking. What I forget is here is a friction force. So friction force will be able to write friction coefficient times the normal force. This equation is magnitude only. There is no direction mentioned in this equation, but friction force always parallel to the surface of contact, right? So normal force is perpendicular, friction force is parallel to the surface of contact, and also it is opposite direction to the motion. So those things we discuss in this chapter. Okay, so now after we work with the Newton's second law in this lecture, and we move into the elasticity, right? Because that is actually important, because when you apply the force, that object that you apply the force can deform or stretch or compress. That is the oversimplification that we did not care when you use the Newton's law, right? But elasticity is very important concept. The object can deform because of you apply the forces. According to that, we were able to calculate what is the deformations and what is the by using Young's bulk and shear modules. So that will be the elasticity part we discuss. Okay, and so now let's move into the first question. In question number 1, it is very simple that when person ride elevator, how the mass of the person is changing on the scale. So that's the question I'm asking in here. And 65 kilogram person stand on the scale on the observed scale reading, right? It is read in kilograms. In following scenario 9 and draw a pre-body diagram for each case. Okay, let's move into the part A. If an elevator accelerates at 0.2 g, so this g value, everybody know when g mentioned about the lowercase g, we usually use the 9.80 meters per square second and negative y direction. And what is the scale reading in elevator? Okay, so now we need to draw the pre-body diagram first, right? So there is a person on the scale, right? So scale basically showing you the mass, right? So now you're going to bring the scale and the person going to the elevator, and elevator going to accelerate downward direction. So that direction is important. Let's draw. This acceleration is not in the pre-body diagram, but we need to know that for the problem. So that's why I keep it outside, right? And now we need to draw the pre-body diagram. What are the forces acting on this person, right? If you take the person, we know that there is force of gravity and there is normal force. We don't know these two forces are equal yet, because since it is accelerating, we need to use the Newton's second law. I don't know even which one is greater. That's what we're going to find it out in the question, right? So as soon as you draw the pre-body diagram, it is very important you use your coordinate system, that you know which direction you use Newton's second law. This is my coordinate system, right? So in this case, all the information is in vertical direction. That means I just need the vertical directional informations, right? So now we're going to write Newton's second law. What is the Newton's second law? For that, I'm going to write net force equal mass time acceleration towards y direction. I need this all steps when you do it. So you are using this equation towards y direction. Left, right also y direction, right side also y direction. Okay. So left I have only forces. What are the forces I have? I have normal force, positive direction. But force of gravity is in negative direction. And mass does not have the direction, but acceleration have a direction. Acceleration says downward direction. That means I should have negative mass time acceleration, right? So now what is the scale reading? Scale reading, it's very important that you understand the difference between scale reading. Scale reading, I need to give in kilograms, right? That means it is not the normal force, but the coefficients that you have before G is the kilogram, right? Because that's the mass. Okay, so now let's write, we know that I need to find the normal force equal, I'm going to add the Fg into the both side, Fg minus M and A. As soon as you write it, Fg we know it is M times G, mass, and M times A. And since M is common, I can take G minus A. Now A is in the question given 0.2 and G. Okay, G is not gram here, G is the value given. Okay, so now normal force in part A, I will be able to write, you see, G minus 0.2 G is 0.8 times M times G, right? So now this one I know M is 65, right? 0.8 times 65, 0, and G if you do the calculation, your normal force going to be 0.8 times 65. That is 52 mg, right? So that is not my question is. So it's asking the scale reading. Scale reading is just the mass. Scale reading equal 52.0 kilogram. That is your final answer. That means important thing is when the elevator going downward direction, what happened to your mass? So your mass is less than the real mass in outside the elevator. Okay. So now we're going to do same thing for the B. And I will reduce number of steps because I did the detailed calculation for the first part. And since it is almost same for the other parts, we're going to do it quickly, okay? B is asking, what is the scale reading if the elevator goes down at a constant speed? So now drawing free body diagram, again you can draw it, right? So there is a person on the scale and going downward with constant speed. What that means? Constant speed means acceleration equal 0, right? And then I have force of normal and I have force of gravity. You may already see what is happening in here, right? But let's do it each step. So I have, I'm sorry, it did not make color, but y direction and x direction. And we're going to use upward direction, net force equal mass time acceleration. Upward direction force is normal force minus f of g equal mass time acceleration, now 0. Because of that, normal force equal force of gravity, that will be equal m and g, that will be equal 65.0 mg. So that means the scale reading is equal 65 kilograms. Okay, so now we're going to move into the C. So that means the scale reading does not change. See if if elevator goes down as pre-fall, what will happen to the scale reading? Make a space in here. See now you have exactly same way, but now acceleration is free fall. When the acceleration free fall, A value will be G, right? So again, you have the same free body diagram, right? And we're going to see what will happen to the normal force in this case. X direction and Y direction, label it, and you have to use X, Y direction, net force equal mass time acceleration. Always write each formula. This is fundamental formula. Rest is the derivation of the formula to the correction. Okay. Sum of F is normal force minus Fg equal. So now negative direction M and acceleration is G. So now in this case, I will be able to write Fn equal, I'm going to add Fg to the both side, mg minus mg. So now normal force equal 0. So that means scale reading 0 kilogram in this case. And let's move into the part D. In part D, if elevator goes up with constant acceleration 0.2, now elevator going to be go up, right? So you have same free body diagram, person sitting on the elevator, and we have force of gravity, we have normal force, and now acceleration is upward, value is 0.2 g. Okay, so now we're going to use Newton's second law, upward direction force equal mass time, acceleration, and we have normal force of gravity downward. And now my acceleration is positive, that is 0.2 times g, right? And so now we're going to calculate the normal force, add mg into the both side. And this will be equal to the 1.2 mg. So normal force equal 1.2 times m. M is 65. And then you will get 78 g. So that means scale reading is 78 kilograms. Okay, so in this problem, I want you to see how the scale reading is changing according to the elevator going up, down, constant velocity, or free fall. Okay. Okay, so now let's move into the next question. Question number 2, right? So it's very important that you draw the cartoon in physics, otherwise it is not going to work for the physics problem. Drawing cartoon and draw the free-body diagram is very important steps on the questions. Okay, so 5 kilogram block sits on the 30 incline. It is attached to a string that is thread over the pulley mounted at the top of the incline. 7.5 kilogram block hangs from the string. Okay. So now let's draw it. And draw it in here. So you can draw the incline this way, or you can draw the incline this way, right? According to that, you need to follow the your problem. So now whatever you draw first, keep consist with that. Don't change that during the calculation. So I have incline like that, right? So now I have object. I have a pulley on here, right? I have object on the inclined plane, and that object connect to this string and hanging down on the other side, and there is an object hanging here. Okay, so now you can label those things. If question given the labeling, you need to use it. If question is not given the labeling, you need to carefully use the labeling throughout the problem, M1 and M2, right? As soon as you write it, let's write down those. M1 equal 5 kilograms. M2 equal 7.5 kilograms. And the angle that I have it in here, this angle is theta, and theta angle is given 30 degrees. Right? So now it's asking you to draw the free-body diagram. So draw the free-body diagram on your picture. Don't draw it anywhere else. Then whoever grade your things are not able to understand what you are doing, right? Because of that, draw the free-body diagram on the drawing you have. So now we need to draw it for the both objects. Let's draw it for the M1. So M1 have how many forces we have? We should have a force of gravity. Always draw it on the center of mass of the object. So we have force of gravity straight down. See, we already know how to calculate it. That is M1 and G, right? And in addition to that, this object, since it is sitting on the inclined plane, there is a normal force perpendicular to the plane. So perpendicular to the plane, I'm going to draw it this way, normal force. Do I have a formula for that? No, there is no formula, right? And then in addition to that, since it is connected to the string, there is a force that we call it as tension force, force of tension, right? So now in the question on the later on, talking about the friction. So because of that, there should be a friction force. friction forces depend on the direction of the object. So direction of the object, you can decide, right? Usually since M2 is greater, this object will go upward direction. But in physics, it's very important that your final answer will make sense to you at the end. If it is going up, you're going to get it as a different sign than going downward direction. Because of that, you can choose, unless question is not given the direction of the motion, you can choose the direction as you wish. That will keep consist with that direction throughout the process. Okay. So now in this case, I'm going to use the direction of the object or the acceleration of the object in this direction, and I label it as acceleration. As soon as I label that acceleration going up, this object should be going downward direction. So now, since I label the acceleration going up, then I know that friction force I need to label downward direction parallel to the surface. This is the force of friction. Okay, that is the free body diagram for the object number 1. And you're going to do the same thing for the second object. Now, second object is easier. You have force of gravity of the second object will be M2 and G. And there is a tension force of tension. Your M1 and M2 both have the same tension force because we're going to use the same uniform string throughout the process. So now we are ready. We are done with the part A. Okay. So now write the Newton's second law for both objects by choosing X and Y coordinates. So this is very important step that you should select your X and Y coordinates on the diagram. That will be a part of the question that I am asking you to do during the process. Now that I probably need more space in here. Let me make a space, then it will not need to scroll up and down. Okay, so now next step is drawing your X and Y axis for M1 and M2 separately, right? So M1, I suggest, it is my suggestion, and it is the easiest way to solve the problem. If you have inclined plane, don't choose your regular X and Y directions. That will be make more steps for your problem, and it will get complicated, and you need to solve a lot of formulas at the end. Easiest way to do it, choose your inclined direction as your X direction. You can do upward or downward, it doesn't matter. But choose direction and keep consistent throughout the process. So I'm going to use on the plane as X direction and perpendicular to that as Y direction. These two should be always perpendicular to each other wherever you draw it. And for this object, I can easily draw the same direction as I have, X direction and Y direction. I'm going to label it in here. This is my X direction, this is my Y direction for the second object, for the first object and the second object separately, right? So now we're going to move into the part B. Part B asking you to write Newton's second law, see, for both objects X and Y direction. Sometimes both direction may not need to solve the problem, but I'm asking you to write it, so you should write it, right? So now we're going to choose first object. Right, I'm going to do it for the M1 first. Okay, M1, we need to write Newton's second law towards Y direction. Now you see Y direction is not vertical direction. You can probably draw it like this. You're doing for Y direction, right? Net force equal mass time acceleration. So now when you do that for the M1 Y direction, what are the forces you have? You have normal force in Y direction. And if friction and if tension are 90 degrees to Y direction, then you do not have components from friction and tension towards Y direction or negative Y direction. But force of gravity has the component towards X direction and Y direction, right? So now that you need to identify, or if you want, you can draw it on the diagram, but make sure you draw it by using dotted line, not to confuse that this diagram, if you complete your parallelogram, you know that there is a force x component or y component in this direction and x component in this direction, right? So now you need to make sure by using geometry, do you know any of those angles? How do you know that? So now since this is 30 degrees, you know that this is 60 degrees. And then whenever you see that, you need to identify your angle here that I have, this angle. Double check that if you don't understand, or ask if you don't understand. That angle is theta. Why? Because this angle I have 90 minus theta, and then this angle 90 minus theta, this should be theta angle. Okay, so you write it down. After you know it is theta, you know that you can write this arrow in y direction, that is negative direction, right? The downward one that I am calculating here will be hypotenuse time, because you are searching the adjacent, right? Adjacent means cosine of that. So I have M1G, make sure that you use correct notation, or that is FG of the M1 times cosine of theta, right? There is no any other force in that direction, should be equal to the mass time acceleration. So now you see that there is no acceleration towards the y direction, right? There is no acceleration towards the y direction. So now, as soon as you know that this will be equal to 0, now I can directly calculate the normal force if I want. Since I'm not asking it, I will just keep it as this. If n equal m1g and cosine of theta. We'll plug the values later. Let's label that equation as number 1. So now we're going to do m1 in x direction. Now we're going to do it on x direction. Net force equal mass time acceleration. Now x direction, you have tension force, right? Tension force in x direction. And then you have friction force in negative x direction, friction force. And now you have FG x component, right? That is seems to be negative direction. That will be M1G and sine of theta should be equal to the mass of the object, that is M1, times the acceleration is in x direction. Because of that, I have M1 and A. Right, so since we do not know any of the information, I'm just going to keep it as number 2, because purpose of the B part is writing Newton's second law for each object. So we are done with the M1. Now we need to do it for the M2 object. M2 object is easier, right? Because M2 object in y direction, net force equal mass time acceleration. That means I have tension force in x direction, but M2G is in negative y direction, should be equal to the mass of that object times the acceleration, but that also to the negative direction, right? So now this one, I think we can calculate it. Let's rewrite it. Ft equals M2G minus, you can write it as your third formula. So now, since second object does not have y direction, there is no any motion to the y direction, there is no Newton's second law for that direction. We don't want it because net force equals 0 in that direction. Okay, so that's it for that. Now let's move into the part C. Calculate tension in the string if the acceleration of the system is 1.2. So acceleration of the system is given 1.2 meters per square second. Now, by watching the formulas that you write, you see that I need to calculate the tension force. I can directly use formula 3 to calculate the tension force, but your question may be in the exam different. But after you write in these 3 formulas, maybe I ask calculate the normal force of the M1 object, right? Calculate the friction force. I can ask a different question in here, but here I am asking the tension force. I can directly calculate it by using formula number 3. From formula number 3, tension force is equal. Write it down one more time, G minus A. Now time to plug the values. So now M2, we know that it is 7.5. It is in kilograms. G we already know, 9.80. Acceleration is given 1.20, and then you will be able to write the tension force as your part C in newtons. So I need more space for the question, and tension force 64.5. Okay, so now let's move into the part D. What's the part D is asking? So now part D is asking, calculate the friction force. Now you need to think, to calculate the friction force, can you calculate the friction force by given formulas? Let's say. So now you see that in the equation number 2. Equation number 2, there is a friction, right? Other formulas does not have the friction. Now, since I have the tension, I will be able to use the equation number 2 to find the friction. So equation number 2, friction will be equal to, let's solve for the friction first. Friction is equal to force of tension minus M1G sine of theta minus M1 and A. So now you're going to plug that. We have, let's plug it on here, 64.5 is the tension force, minus M1 is 5 kilograms. 5 kilograms, G is 9.80, and sine of 30, sine of 30 is half, right? And minus M1 is again 5, and acceleration is right on the top, 1.2. So plug into the calculator, and then you're going to get the friction force in units of newtons. What I have is 33.9. Okay, so part E, calculate the coefficient of kinetic friction. So now I need to calculate the coefficient of kinetic friction. After I know the friction force, only formula for the friction force, we know that that will be mu k times the force of normal. So I need to find the mu k. This formula does not have a direction. So friction force divided by normal force. So now friction force we already calculated, and normal force is, you see that in from formula 1, normal force is M1G cosine theta. So M1G cosine of theta. So now you're going to plug that and calculate. M1 is 5 kilograms and G is 9.80, and cosine of 30 is √3/2, and then you will get mu k is a coefficient. There is no units. Have 0.80. Okay. So that's the order of the question that I have done. So any questions related to Newton's second law should be given in similar way, but it can ask to calculate different thing in the problem. Your problem will be different, but it is exactly same procedure. You need to keep doing it very slowly, very patiently, and then you will get it. If you miss up one negative sign, your total answer will be wrong. Okay. Because of that, do it very carefully when you do the question. That's why those steps are important, because when I see the steps, although your final answer is incorrect, I know that you have some knowledge that how to deal with this kind of question. But if you have final answer which is correct or wrong, you will get 0, because I am looking for your learning experience and also the way you follow the steps as I discuss in the lecture part and the worksheet. Okay, there are many questions that you can do belong to that kind of Newton's second law question. Okay, you can do horizontal motion, you can do vertical motion, you can do incline. Incline is the hardest one, other ones will be easier, and you can easily do them if you know how to write Newton's second law correctly. Okay, so number 3 is little different question, because since we talk about the drag force, this question is talking about the how you implement the drag force in addition to the free fall. Because free fall, we know that object is keep falling and velocities keep increasing downward direction. But drag force, when there is a air resistance, there should be a drag force. Because of that, when the drag force is equal to the force of gravity, then object going to not do the free fall, object going to select the terminal velocity and move with that constant velocity until it hit the ground. Okay, that's why drag force is important. The object dropping from very top height, so then they may have a terminal speed that is probably not free-falling after some time, because it will reach the drag force equal force of gravity. So now we are talking about the raindrop here. So we have raindrop, and R is 1.5 millimeters. Is very important that we work with the units in here, right? And then we have height, meters, and drag coefficient given, density of water is given, density of air is given. So now, first calculation, it's asking me to calculate the force of gravity of the raindrop. So force of gravity of the raindrop, we know that we can calculate by using mass and the G. Now problem is, in the question, mass is not given. Mass, how do you find the mass? So we know that how to write the density. Density equal mass over volume. Then I can write the mass equal density times the volume. Right? So if I have information about the density and the volume, I will be able to calculate the mass. Okay. So now density, we are talking here is the raindrop, right? Raindrop, we're going to assume it as a spherical volume, and that means volume of this one will be able to write volume of the sphere, that is 4 pi r cube over 3. R is the radius of the raindrop, right? So now if the density of the water is given, we will be able to calculate now mass equal density rho of the water times the volume 4 pi r cube over 3, right? So now you can plug the values. Since density of the water is given, you see that density of water is around 1000, right? And 4 pi, and use the radius in meters. So that means I have 1.5 millimeters, 1.5 millimeters. So you need to do it into the meters, right? How do you convert millimeters into the meters? You know it, right? So 1 millimeter is equal 0.1 centimeter, right? 1 centimeter is equal 0.01 meters. So that means 10 to the 3 I need to do. So that means 10 to the negative 3, but I should have power 3. That is the R power 3 and divide by 3. Okay. So you plug that into the calculator and calculate the mass. Mass I get, I hope my answer is correct, 1.41 times 10 to the negative 5 in kilograms. That is what my mass is. So now as soon as I found the mass, I can go and calculate the f of g. So that will be 1.41 times 10 to the negative 5, and g is 9.80, and then f of g in newtons will be very small because it is a 1 train drop that we are talking, negative 4 newtons. That is the force of gravity of the train drop. Okay, so now let's move into the part B. So part B is asking, calculate the terminal velocity when the drag force is equal to the gravitational force. Drag force is equal to the force of gravity. So at some time when the drop is falling down, there is a place that your force of gravity going to be equal to the drag force. After you reach that terminal point, that is, we call it as the velocity at that time of the raindrop, we call it as the terminal velocity. So now force of drag minus force of gravity going to be 0 at that time. That means force of drag equal force of gravity. I'm just writing Newton's second law here. Net force equal mass times acceleration in y direction. That's what I did, right? And now the drag force formula, you have it on your lecture note. So that will be half, and C we call it as drag coefficient, and then density of the media, train drop going to be fall in the media of air, density of the air, and cross-sectional area of the raindrop, the side view, and then velocity squared, that's the drag force, should be equal to mass time g, that's the force of gravity. So force of gravity, I already have it on the right side, but I do not going to plug that yet. I'm going to write the V from here. So I'm going to times 2 first, 2 mg, and going to divide by C, rho A and A. So C, rho A and A, and then need to take this square. Let's rewrite this one more time. 2 mg C rho A times cross-sectional area of the raindrop, but side view that you are seeing on the side view will be pi r n squared and root of. Right, so now we can calculate it. Since all the values are given, you will be able to calculate it. Okay, so let's plug the values. Velocity equal 2 times mg. You already calculate the mg on the top. 1.38 times 10 to the negative 4. That is mg, and going to divide by the, see that the drag coefficient should be given on the question, that is 0.6. That is 0.6. And density of air is given 1.2 in SI units and 5, and r squared also given. Radius of the raindrop we used earlier, 1.5 times 10 to the negative 3 and squared, right? So, and then take the root of this whole thing. You're going to get the terminal velocity. What I have is 7.4 meters per second. Okay, so now we're going to move into the part C. If you consider the problem as free fall only, what will be the velocity? So now, if it is a free fall, we know that this object train is keep dropping with the downward direction, and now if the rain is sitting on the height y, initial going to be 0. This is y final going to be given in the question 1200 meters, and this problem is going down with the acceleration equal 9.80 meters per square second, right? So now I need to find the velocity after it falls down to the ground. So you know that by using kinematics formulas, we will be able to calculate it for the free fall, right? So free fall, you can use the kinematics formula. In here, I can use the third formula. V final squared equal V initial squared plus twice acceleration, y final minus y initial, then V final will be, this is going to be 0, and this is going to be negative twice times 9.80, and V final, y final is 1200 minus 0, then velocity will be equal to negative 153 meters per second around. Right? This is also negative, okay, because it's going downward since you are taking square root of that. Okay, so now you see that the difference. If it is a free fall 153, it's keep increasing, but if it is air resistant, then drag force will equal to the force of gravity, and then terminal velocity 7.4 is keep falling down, right? So that is the part that we discuss in this question. So now last question, I'm going to do it here. This is for you to practice about the elasticity. So, but I have no plan to give you those questions in the quizzes. But since you learn it, it's good to practice it in here. So it's stuck in here. Sorry about that. I have to post the document and reopen it. So now let's move into the number 4. So calculate the change in the length of the upper leg bone when a man supports 62 kilograms of his mass on it. Assume the bone to be equivalent to the uniform rod that is 40 centimeter long and 2 centimeter in radius. So we're going to assume in your bone is a cylindrical shape which has the length and the R is given in the question, right? And now what we need to calculate is change in length of the bone, right? So when you have this 62 kilograms by this length and the radius bone, then your bone will be expand when you apply the force. Now you need to understand this question is asking about the expansion or change of the length, right? Calculate the change of the length. That means basically how much it's going to stretch when you apply this force into the bone. So now, according to the information given, cross section, we know it is pi r squared, right? So you will be able to calculate it since r is given. Make sure centimeter convert into meters, right? So 2 centimeters convert into meters, 10 to the negative 2, and take the square of that. And then you can find the cross-sectional area. I have 1.257, 10 to the negative 3 meter squared. Okay. And then length L0, I'm going to take it as the length L0 here. That is the 40 centimeters. That will be 0.400 meters. And then force applied on the object is force of gravity in this case. Force of gravity equal m and g. So since we have m 62.0 and g is 9.80, that will give me the force as 607.6 newtons. Okay. And then in addition to that, Young's module is given, right? So Young's module, we use the uppercase Y for that. That is 9, right, 166 in there, 10 to the power 9 newtons meter squared, right? So now those are the given informations. What we need is expansion of your bone. So now we know that this is linear expansion, so that we can write it as your delta L. That means after you apply the force, it's going to stretch delta L amount. That will be equal to the formula 1 over Young's module times force per unit area times the L naught, right? So we have those all the informations. We're going to plug it into the calculator, and F is 607.6, going to multiply the L naught and going to divide that by Young's module 9.0 times 10 to the 9 and cross-sectional area 1.257 times 10 to the negative 3. Then you're going to find your delta L value. I have 2.0 times 10 to the negative 5 meters. That's the expansion because of that force. Okay, so that is the Young's module, that means linear expansion. And in addition to that, there may be your shape of the object can be a different area expansion, right? If it is an area expansion, then you need to use the shear module, how the area change. So that's the question B I have it in. So now you have a rectangular block, right? 0.25 cross section. So A is 0.25 in SI unit meter square. The height of the box is 0.2 centimeters is, I'm going to write H. Height of the box is 0.02 meters. And the shear force applied to the top of the face produces a displacement, this much. Displacement, we're going to write it as delta X will be 0.015 millimeters. I'm going to write it 10 to the negative 3 meters. Okay. And find the shearing force by taking the shear module, this much. Shear module, we use the letter S for that. That is 4.5 times 10 to the power 10 newtons over meter square. So when you identify this is a shear module, that means you have a rectangular shape like this. And then after you apply the force, this going to be changed into your new shape. This is what will happen, deformation of the object, right? This height, this is the H is, right? This is what your delta X is. All right. So now according to your formula that you learn, delta X will be equal to 1 over shear module times F over A. And then in this case, it is H, or you can use L naught if you want for that. H or L naught. Okay. I use. Okay, so this is delta X. I need to solve it for the force. That's what the question is asking. You see. Find the shearing force. Okay. Shearing force. I need to find the shearing force. So shearing force will be equal. You can find the solve it for the force first, and delta X times S and A, and going to divide by H, right? So now we can plug the values. Delta X is 0.1015 times 10 to the negative 3, and cross-sectional area is 0.25, going to divide times first your shear module, and you're going to divide by the H, that is 0.0. So now your force will be equal to, what I have is 8.44 times 10 to the power 6 meters. Okay, so now let's move into the last question. Last question, I want you to think the volume expansion. Calculate the fractional decrease in volume. Fractional decrease in volume, that is what you need to find, right? For the seawater, 5 kilometers depth, bulk module seawater is this one, and density of seawater is this one. So density of the seawater is given 1.03 grams over centimeter cube, and depth, going to write it as 5 kilometers 10 to the 3 meters, right? And then we have bulk module, we use the B for that, 2.2 times 10 to the 9 Newton over meter square. So now for the bulk module, you know that we can write the formula given in the textbook, delta V equal 1 over B F over A and V naught, right? So delta V over V naught is the one I need to find it out. V naught equal 1 over B and F over A, right? So now it's very important in here. F over A is actually not given, but this we're going to learn a little later on the your semester. F over A, we call it as the stress, or we call it as the pressure. Stress or pressure, same word. Okay. So now this will be able to, F will be able to calculate by using Archimedes principle or the Pascal principle. So we call it as force. So now this pressure, the force over area, we call it as the pressure. That means pressure is equal F over A. Will be able to calculate by using Pascal principle. That is going to talk later on the semester. Density of the fluid, in this case it is water, and G and the depth of the depth where you're going to calculate the pressure with respect to the atmosphere. So now this will be able to calculate by using this. That means F over A in your question is calculated by using these informations. Okay, so density is given. Then you know that you need to convert that into SI units, right? This is density grams over centimeter cube. That will be, I need kilograms over meter cube. Okay, convert grams first, 10 to the negative 3 kilograms, and divide by centimeter cube, centimeter into meter, 10 to the negative 2 times 3, right? You convert into that yourself. So gram over centimeter cube, and G is 9.80 and H is 5.0. I'm going to type on the top, 10 to the power 3 meters. Now everything is in SI unit, and we're going to get F over A on this. F over A, I have 5.05 times 10 to the power 9 newtons over meter squared. So now I can plug that into here. Since B is given, we will be able to calculate the delta V over V naught. So I have 5.05 times 10 to the 9, that is my F over A, going to divide by B, that is 2.2 times 10 to the 9. So then I will be able to calculate delta V over V naught is equal okay, so it seems to me this is 10 to the power 7, not 9, okay, because otherwise it will be a greater value than expected. This is 7, okay, and this value I have 0.023. Okay, that's it for this worksheet.